greatly the research community as well, because a lot of work has been done the last 10 to 15 years in the IR and the natural language processing field and the machine translation field, and many groups that they produce small tools, they have great difficulties to transfer these tools from research labs to production. And that can be a very good framework for quick adoption of a tool, of a search tool, which will become available to this ecosystem.
Other questions?
I have a question. Do you also consider dependencies and overlaps when you are using those different tools? So I can suppose that there are results or...
There will be many.
Yeah.
Definitely.
Yeah, and how can these be managed?
Well, basically, overlaps can be important to have, because that gives the option to the user or to the solution, to the search solution provider, to provide many different options. For example, just imagine that you've got a visualization of a search result. And what you would like to have is to have multiple search tools, if possible, that can visualize search results and then leave to the user which tool is going to use. Or we would like to produce many different faceted views of the same result list. I think overlap is important. It may be another complexity factor, but at the same time, it is a lot about competition. So what we need is, we need to identify clear the tasks that need to be performed, and that's the, probably, that's the part that the framework will provide. So for example, the framework, we say that we have a class of tools which is called faceted navigation. How faceted navigation exactly is going to be implemented will be left to the tools. So it's very likely that overlaps will happen quite often. And that's part of the synchronization problem, I think, I guess.
Thank you. Okay, so thanks a lot. We really appreciate your talk, and thank you.
So I tell my class when they sit quietly after a lecture and don't ask questions that the questions are part of your grade for the course. So,
We all fail.
what?
We all fail.
We all fail. So our next speaker is Mike Conway from the University of North Carolina at Chapel Hill. He's at the Research Computing Institute there, and he's the integrated architect of the Data Intensive Cyber Environments Group. It's an impressive title. He's also currently a master's degree candidate at the School of Information and Library Science at UNC, and he does research on metadata for distributed data grids, policy management, and trusted digital preservation. Welcome, Mike.
If I may, I can run through my laptop or is the presentation.
Sure.
You can do whatever you want.
Yeah.
Good morning, everybody. I have to say that was a wonderful talk, and so I'm going to eagerly run back and talk about all the potential mistakes we may be making in terms of integrated search and some of the cautionary observations that were made. So my talk today is on the DFC Semantic Technology Platform and Hive Innovation, and this is a collaboration that we're doing with the DICE group at UNC, as well as Jane Greenberg and her Metadata Research Center at UNC. And it's sort of a happy coincidence that the two groups are working together at the School of Information and Library Science, and we're finding a And the two projects that are involved are the one I work on, the DataNet Federation Consortium, and then Jane's group is working on what she calls HIVE, developing interdisciplinary vocabulary engineering. So if you will, DFC is an effort funded by the National Science Foundation in the US to create national scale cyber infrastructure. And metadata plays into the DFC in a couple of ways. And if I may talk about the larger issues, here we're concerned about metadata for powering this kind of integrated federated search. So metadata for discovery of scientific data that resides on the DataNet grid. We're also concerned with metadata in terms of digital preservation and the life cycle of scientific data, all the way from, for example, a model run or data coming off of a glider at the Ocean Observatory, all the way to reference collections. So how can we use policy and preservation to preserve metadata from the source all the way to, for example, a reference collection that might be used in research. And then, if I may link to a talk we're going to do tomorrow concerning some of the work I'm doing with some other colleagues, there's also this idea of metadata for trusted preservation. So how can we use metadata to make assertions about provenance and the quality of data, for example, that might exist in a reference collection. Okay. So HIVE, I want to introduce briefly HIVE. And HIVE is about tools. And so a couple of the things that really were attractive to me were the fact that HIVE is focused on providing tools to curators. So to our perception, one of the biggest problems we're going to have is getting people who are putting data onto the national grid to actually curate their data, to annotate it and make it findable. Okay, so HIVE provides a framework for tools that allow easy search, navigation, and discovery of vocabulary terms in this case. It's a framework for managing and navigating across multiple vocabularies. And another thing that's important is it is a framework, so it's agnostic to what the particular vocabulary is or what domain is actually using those vocabularies at the time. And so, like the DataNet that is open to many different kinds of disciplines, we want to create frameworks for metadata also that will accommodate as new disciplines like climate science and hydrology, learning, engineering, and all these different domains come together. And it focuses on SCOS as an approachable semantic metadata solution. So we are looking for simple tools that are approachable for people. And HIVE is a component service so that we can import multiple SCOS vocabularies, and it provides the framework to index all these vocabularies with Lucene as they're imported and populate triple stores for navigation. It creates an infrastructure that allows you to search and manipulate multiple vocabularies as you're curating data. And also, interestingly, it supports automatic term extraction using the Kia++ and Maui frameworks, which are natural language frameworks for extracting terms, and they can be trained, these algorithms can be trained by sample documents. Okay, so the key for HIVE is to provide services to allow easy integration of these controlled vocabularies in the workflow of curators and researchers. Okay. So again, it presents a service in a container, because one of the important aspects of DFC is that there is not one interface for everybody. So rather, what we want to do are provide metadata services so that different groups can create their own interfaces for curating and managing their own data. And so with that, married with the IROS, which is the canonical store for both data and metadata, we want to introduce this idea of policy management. So how, in the previous talk when we talked about information sources, perhaps we could think of the IROS grid as a federated set of these information sources. And so how do we synchronize and coordinate, perhaps, as the other talk suggested? And one answer may be that we look at the sort of already established process of policy-managed data preservation. So as we talk about the management of scientific data across its entire life cycle, from sensor sample to research to reference collection, that management of that metadata along its life cycle by integrating policy with the storage on the grid may be a way to achieve some of this synchronization. And this is exactly one of the aims of this project. So the DFC vision from the National Science Foundation is about data-driven science. So this is specifically integrating data from sensors, integrating data from computer simulations and models, and then sharing and collaborating on that research across domains. So we may have the Scripps Ocean Institute providing data that is integrated with data from the National Climate Data Center. And each of these groups may own their data and have their own grid, and so the DFC is conceived of as federations. So you may have different groups that federate parts of their collections with other researchers. So at the outset, we do already have this problem of federated search. So how can a researcher at NASA Goddard, for example, find data that exists on this federated data net? And so again, we run into perhaps some of the things suggested by the previous talk. So it's NSF National Scale Cyber Infrastructure, and also the goal here is to integrate live research into education mission. So IRODS is the underlying technology for the grid, and I think what's important here in terms of metadata is the fact that IRODS across these federations can maintain one global logical namespace, and also that it has a rule engine embedded, and this is where policies are invoked. And so this allows, for example, management of access, maintaining of provenance and chain of custody, data transformations, automatic metadata extraction, and application of NLP tools and things like that. So it's open source, it's policy managed, it's, again, federated, so you can stand up your own grid and federate with another organization ad hoc. And it also has a catalog where it can maintain native metadata for collections and files. So the challenges are this multidisciplinary sharing and discovery of data, and findability of data at large scale. So this is the thing already, for example, with the iPlant Collaborative, who is part of DataNet. They're already into the millions of data objects and maybe tens of thousands of users. So we're immediately faced with problems of scale. And also the idea that there's other data nets, for example, Data One, where Jane is involved with, for example, with the Dryad project, interoperability with these other data net initiatives and other research repositories. So, so linked data, for example, is one of the things that we're looking at as an approach. So this is an opportunity to explore the linked data, especially between DataNet and Data One as a use case, and along these research data grids. We're looking at curation by researchers using Hive as one aspect of this. And can we find consensus naming conventions to achieve some findability? And again, this idea in Hive of being able to use multiple vocabularies and curate using these vocabularies in easy service form is very important to this sort of one approach. Yes, thank you. Okay, so very simply, in this example, Hive, we're importing what I think the Agravoc vocabulary into Hive, and Hive, by the fact that that vocabulary is imported, that vocabulary is instantly searchable, navigable, and easy to integrate into larger systems. So in this case, this is an interface, and they've selected a collection in the data net. And what you can see here, barely, is a view that we call a pivot view, where you can navigate around the SCOFS terms. You can search them with Lucene across multiple vocabularies and then apply terms. They're preserved in the data grid, so the DFC is a canonical data store. And then the strategy here is that we can then use multiple tools and index and create what are essentially ephemeral indexes offline and asynchronously. So perhaps again, this idea of synchronization through the application of policy on the grid would provide indexes in Lucene, in Cheshire, in Jenna, and other kinds of search tools. And I guess the important thing here, how Hive integrates, and first there are the interfaces for the researcher and curator, but also since it's policy managed data, we can apply policies to collections and grids to allow this automatic extraction of metadata using Kia and Maui. So one of the things we're really interested in is bootstrapping the training process for these natural language processing tools. So if we can get collections that are curated to a point by researchers, we can then, once we achieve a certain percentage of documents, for example, we can automatically trigger the teaching process for the Maui-Kia algorithm. So we are really interested in this application of automatic metadata extraction